So, we were in the middle of this decision making with experimentation. Very quick review what we have done so far. Basically, there are three alternatives: construct a large plant, a small plant, or do nothing. And there are two states of nature: favorable market and unfavorable market. And there are these payoffs, and there are some a priori probabilities of 0.5 and 0.5. Now, we can decide a new plant based on there is a market survey option we can also have. So, when we have market survey, it has a cost of 10,000, and the market survey actually gives a set of conditional probabilities for survey favorable given favorable market or unfavorable market, and similar thing for survey unfavorable. So, these are the conditional probabilities. Then what we did is a Bayesian analysis, and in that Bayesian analysis we calculated the prior probabilities already known, the conditional probabilities are given. Based on these prior probabilities and the conditional probabilities, we calculated what is known as the joint probabilities, and from the joint probabilities, by taking the similar cases of the survey results, that is survey favorable and survey unfavorable, we could obtain what is known as the unconditional probabilities. And after obtaining the unconditional probabilities, we could actually obtain what are known as the posterior probabilities, and those posterior probabilities are for two cases: favorable market given survey favorable, unfavorable market given survey favorable, they are 0.78 and 0.22 respectively, and similarly for survey unfavorable, the values came to 0.27 and 0.73. But look here, there is something more to it. Look at this particular diagram. In this diagram, what we have done, we had done what is known as Bayesian analysis. And in this Bayesian analysis, what is basically important here is that one side we have, these are the a priori probabilities, that is the favorable market and unfavorable market, and then we did the survey, and then we did the the Bayesian analysis. We obtained the conditional probabilities and obtained joint probabilities, etc. But after the posterior probabilities are obtained, then look here, this diagram is now changed, right. Now, we could draw actually the decision tree in a different manner. What is the different manner? We could put the decision first, right. What was the decision? Decision was whether to go for survey or not going for survey. Now, the result could be two. It could be either survey is favorable or survey is unfavorable. If the survey is favorable, what was the unconditional probabilities? The PSF was 0.45. What was the unconditional probability for survey unfavorable? It was 0.55. So, we put them here. Now, there could be two situations. It could be favorable market, it could be unfavorable market, right. Basically, the survey says it is favorable, but in spite of that, actually because of uncertainties, the market can actually be favorable or unfavorable with posterior probabilities of 0.78 and 0.22. Similarly, if the survey comes out to be unfavorable, it could be favorable market for 27% time, and it could be unfavorable market for 73% time. So, this is the net result out of our Bayesian analysis, and we can then put this result into our decision tree. Now, let us look how we can do that. These are our calculations. So, after these calculations, so look here how the decision tree of the problem can actually look at. So, look how this particular decision problem actually is looking after. So, what we have done? We have now reconstructed the whole thing. That how we have reconstructed the whole thing? Let us look here. Now, at the very first decision point, there are two decisions for the decision maker, that is the company. What is that? Either it can conduct a market survey or it may not conduct a market survey. If it does not conduct the market survey, then this part of the problem is nothing but the original decision problem that we have taken up in a class, right. We have already taken up this problem, which is the decision tree problem without experimentation. That means, we have not conducted survey. And what are these situations? Then we had three options: large plant, small plant and no plant. If we go for large plant, there are two states of nature: favorable market or unfavorable market, with probabilities of 50-50 each. And similarly for small plant, and these are the payoffs. Now, on the other hand, suppose we actually conduct the market survey. Then when we conduct the market survey, then we found that unconditional probabilities are the survey results favorable, that is 0.45, and survey results unfavorable 0.55. These are the unconditional probabilities. And what are the your posterior probabilities? These are the posterior probabilities, right. Supposing if the survey results are favorable, then favorable market was 78% and unfavorable market was 22%. But if the survey results are unfavorable, then favorable market was 27%, unfavorable market was 73%. So, those are the things, and that could be constructed for the different decision points. Now, look at this thing once again. What we had done? What we have done is that this is where we gave the unconditional probabilities, and for each case we are getting two situations where we put the posterior probabilities, the favorable market, unfavorable market, favorable market, unfavorable market, and these are our posterior probabilities. Now, look at the slide once again. The same 0.78 and 0.22 and same 0.27 and 0.73, they are actually put here. Now, what is then the experiment has actually done? Look here, when we do not conduct the survey, we do not know exactly the ground situation, and therefore, there is an 50-50 chance that there could be favorable market, unfavorable market. Why? Because we do not know, our knowledge is limited. But when you have conducted market survey, if the result comes out to be favorable, then we believe that favorable market may come is 78%, because that is what survey have said. The survey have said that the survey results are favorable, but if survey results have said results are unfavorable, then favorable market falls to 27%, right. So, this is exactly what we have to do really when we do experiment. We have to bifurcate the decision points, we have to obtain the unconditional probabilities as the states of nature when we conduct market survey, and at the second decision point when those original decisions are taken again, and the corresponding states of nature which were favorable market and unfavorable market, we have to write what is known as the posterior probabilities, right. So, when we do that, putting posterior probabilities here and putting the unconditional probabilities here, which are the results of the market survey, we have been able to construct the decision tree, right. So, if you look at this decision tree carefully, then this particular decision tree has got 7 different points where we have to calculate what is known as the payoffs, right. 1, 2, 3, 4, 5, 6, 7, right. Those payoffs are to be calculated, and look at the payoffs, they are written there also. If we do not conduct survey, then the payoffs are coming out to be 200,000, minus 180,000, 100,000 and minus 20,000. But the survey itself has a certain cost, and that cost is 10,000. So, that 10,000 is now deducted from each of the payoff. So, therefore, this becomes 190,000 minus 190,000, 90,000, 30,000 and no plant minus 10,000. Why? because survey has taken up 10,000, right, and similar payoff figures here. Sometimes people do not believe in the payoffs and they calculate what is known as another term called utility, right. Sometimes the payoffs may be high, but utility may be a little lower than that. Sometimes the payoffs may be low, but utility may be still some value. So, basically utility is a function of payoff. So, instead of really using payoff, some people actually use utility. Anyhow, we are not going to use utility here, and we are going to use the payoffs as they are. So, these are the some calculations. We will show the calculations later. First, let us see how the decision trees are actually obtained, right. So, you can see here that these calculation, if favorable market is 78%, unfavorable market is 22%, and the payoffs are 190,000 and minus 190,000, then the actual payoff that will be obtained is 0.78 into 190,000 plus 0.22 into minus 190,000, and it comes to 106,400, right. On the other hand, if we go for a small plant, then because of 90,000 and minus 30,000 payoff, it comes to 63,600 as the payoff. For no plant, it will be minus 10,000. So, now again these are the different payoffs: 106,400, 63,600 and minus 10,000. When we combine them all, we get 106,400. So, that is the payoff that we get, and it comes from going for a large plant, right. Go for a large plant and you will get what is known as 106,400 as payoff. On the other side, if we go for the survey results are unfavorable, there the payoff calculations are showing minus 87,400 and 2,400, right. And with those calculations, the 2,400 and this is minus 10,000, this is the only positive term, rest are negative. So, we actually go for the 2,400, and this calculation we had already done, that is 40,000 as the net calculation, that was with our going for the small plant that we have already seen. So, do not conduct survey, So, if you look at the ultimate decision, because there was 45% and 55% weight. So, if we put those weights, then the net payoff comes as 106,400 into 0.45 and 2,400 into 0.55, that is 49,200. That is our payoff, 49,200. That is payoff for if we conduct market survey, and if we do not conduct market survey, it comes to 40,000. So, since 49,200 is higher, we go for 49,200. So, at the first decision point, finally, the evaluation is the net payoff is 49,200, and it is better to conduct market survey because payoff is higher, which is higher than 40,000. So, go for market survey. Now, after going for market survey, two states of nature: survey favorable, survey unfavorable. If survey is favorable, then 106,400 is the second decision point, and it is better to go for large plant. But if the survey results are unfavorable, then go for small plant, right. So, this is the situation that actually can happen, and if you do not conduct survey, the decision was small plant, right. So, this is the decision. Let us write down the final decision here. The decision number 1, conduct market survey. If number 2, if market survey results are favorable, then construct large plant. else, that is market survey results are not favorable, construct small plant. Right. So, this is the final decision, that is we conduct the market survey because that gives better payoff, and then if market survey results are favorable, then construct large plant, and else construct small plant. So, you see the advantage here is the based on market survey results we can actually change our decision points. So, that is how to construct really. We will take up another example later on, so that the understanding becomes clearer. Now, before moving on, there are two most important decisions that are also to be decided by the company. First of all, the company is not sure how much value to place on market survey, because in this case we have given 10,000, but one should know also that okay, we are going to have market survey, how much value should we put. So, they want to determine the monetary worth of the survey. Company is also interested in how sensitive the decision is to changes in the market survey results. So, sometimes that sensitivity analysis is also required. So, two things are important: what is the expected value of sample information, here market survey, and second is a sensitivity analysis. So, the EVSI really tells how much money to place on the market survey, and sensitivity analysis tells that what should be the changes in the decision based on the market survey results. So, let us look at the first one, that is expected value of the sample information. Sometimes it is called EVSI. So, EVSI is defined as the increase in expected value resulting from the sample information, right, resulting from the sample information. So, in this case that expected value of sample information is the expected value with sample information minus EV without sample information, right. So, in this case 49,200 is the actually we got, but then 10,000 we paid also. So, if we add that, then 59,200 would have been EVSI. So, another way of looking at it is what would have been the expected value of sample information without considering the cost, that is also. So, that would have been 59. If suppose there was 0 cost for that, then what would have been our expected value? So, it would come to 59,200, and this 59,200 and 40,000 is if sample information is not available. So, net difference is 19,200. So, that means the company could have paid up to 19,200 for a market survey, but the survey actually costs 10,000. Let us look at the diagram once again. So, we have got 49,200, 10,000 we paid for the survey, that means another 10,000 we could have got. So, these 49,200 would have been 59,200 if the market survey would have been obtained at 0 cost. But if we do not conduct survey, then our payoff is only 40,000, right. So, that means this 59,200 minus 40,000, 19,200, that is our EVSI, expected value of sample information, right. So, expected value of sample information once again is the expected value with sample information plus the cost that is given, and that is the expected value that we have obtained minus the expected value without sample information. So, that means the company could have paid up to 19,200 for a market survey, but the survey actually cost 10,000. So, therefore, it is worth going for the survey, right. That means survey is meaningful. The second important thing is what is known as the sensitivity analysis. So, the question here is how sensitive are the decisions to change in the probabilities, right. How sensitive is our decision to the probability of a favorable survey result. That is, if the probability of a favorable result p equal to 0.45 were to change, would we make the same decision? How much could it change before we would make a different decision? So, what was that 45? Let us look at this diagram once again. Here we see that survey favorable 45% and survey unfavorable 55%. Here sensitivity means that suppose this survey favorable result is not 0.45 but 0.40, right, and this survey unfavorable result is not 0.55 but 0.60. So, when these 0.40 and 0.60 they changes, let us say that posterior probabilities still remain constant because of the way calculation are done. Suppose, let us, this is only assumption, suppose we make this assumption, as long as these probabilities remain same, these payoff values would remain same also, right. So, what happens, but if it is less favorable towards this and more favorable towards the other side, then this 49,200 would have reduced, right. Now, obviously, how much margin we have? The margin is 40,000 only. The moment it goes below 40,000, then the situation becomes, the sensitivity result shows that conducting market survey is meaningless. So, therefore, there is a certain probability of here the total probability or unconditional probability of the survey results becoming favorable, beyond which it is not worth really going for the market survey. So, let us look at this once again, about the sensitivity analysis, that if we do a calculation, then we find that if the probability of a favorable survey result is p and 1 minus p is the probability of an unfavorable survey result. So, the expected monetary value would be 106,400 because that was with the survey favorable and 2,400 with the survey unfavorable. Obviously, these are obtained with there is no change in the posterior probabilities. If the posterior probability values themselves change, then obviously these values, that means the payoff values will change also. So, there is an inherent assumption that those values do not change. So, if we multiply, then we get 106,400 into p plus 2,400 into 1 minus p. So, total expected monetary value is 104,000 plus 2,400. So, we are indifferent when the expected monetary value of node 1 is the same as the expected monetary value of not conducting the survey, that means 40,000. So, if we equate the two, then we get 104,000 p plus 2,400 equal to 40,000. In other words, 104,000 p equal to 37,600. So, what would be the value of p? The value of p comes out to be 37,600 by 104,000 equal to 0.36, or in other words 36%. So, when we have a value of 36%, p greater than 36.36, the decision will stay the same. But if the probability becomes below 0.36, then the result comes out to be do not conduct survey. So, what is the essential meaning of this sensitivity analysis? Let us go back to this diagram once again, that if we have a value of 36%, that means if the survey favorable becomes 0.36 and survey unfavorable becomes 0.64, then these payoff would become 40,000 and these 40,000 would be equal to these 40,000, then there is basically we are indifferent to conducting market survey or not conducting market survey. In other words, we may not conduct market survey, right. So, that means that if the survey favorable probability falls below 36%, then there is it's not worth conducting market survey, right. So, this is exactly what we have learned, that first of all, that whenever there is a decision point and we have to do an experiment. We put that experiment, conduct the experiment or do not conduct the experiment as a decision point, and when we conduct the market survey or in this case the experiment, then the results that can come, they will be the states of nature, and the kind of probabilities, the posterior probabilities that we have got, that would be should be used for making our computations and calculate the payoffs and makes the decision. And finally, calculate the expected value of sample information and also do a sensitivity analysis if possible. Right. So, with that I stop here. In our next class we shall again take another example to really understand in more detail. Thank you very much.